go ahead and pick through the review sheet very quickly. So numbers 1 through 3, are these two things similar? You can see all the angles are congruent, so that's good. Now we just need to make sure the sides are proportional. So check 10 over 15, compare that to 6 over 18. This will simplify to 2/3, and this will simplify to 1/3, which means that these two things are not similar. Number 2, again, all of our angles are congruent. And here all of a sudden that's 50 times 3 is 150, 200 times 3 is 600. So the sides are proportional, so angles are congruent, the sides are proportional, which means these two things are similar. So the first one's not similar, the second one is. The third one, again, we've got congruent angles, a 90, a 40, and the missing angle there would be 50, so all the angles are congruent. Alright, so that's good. Now we just need to check. So the smallest side of the left side triangle is 6, the smallest on the right is 9. We go medium to medium and large to large. And these are pretty simple to simplify. So divide both by 3, that's 2/3. Divide both by 4, that's 2/3. Divide both by 5, that's 2/3. All of these are equal, which means the sides are proportional. Which means, again, we have two triangles that are similar. Alright. Here, if they are similar, find the missing side. So this is just a matter of setting up your proportions. Excuse me, started to set that up wrong. So we have 2 over 4. Right, so we go 2 to 4, and that equals 3 over x. So we cross multiply. 2x equals 12, so x equals 6. The next one, we have 3 over x equals 17 over 68. And so then we'll cross multiply. We end up with 17x equals 3 times 68, which is 204. Divide both sides by 17, and x equals 12. Here we go, 6 over 9 equals 7 over x. Again, cross multiply. 6x equals 63, which means x equals 10.5. And then finally, 1 over 0.25 equals x over 2. Again, cross multiply. So end up with 2 equals 0.25x. Divide both sides by 0.25. And we end up with x equals 8. The next problems tell which similarity theorem, if any, can be used to say that the triangles are similar. So here we've got one angle that's marked. We're also allowed to go ahead and put the vertical angles in there, which means this is similar by angle, angle, right? These is similarity. So similarity, you could do angle, angle, side, 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 or side, angle, side. Those are your three options. Remember the sides, you have to check for proportions. Alright, so sides are proportional, angles are congruent. The next one, it looks like we have an S, an A, and S. Just go ahead and check really quickly. So 2 over 22 and 3 over 33. And sure enough, those are both 1 out of 11. So the sides are proportional, just like we mentioned right here. So the sides are proportional. And then are the angles equal? Well, yep, they got it marked right there. So these are similar by SAS. Notice that I've checked. These look like side, side, side. A quick check. So 5 times 2 is 10. 5 times 2 is 10. 6 times 2 is 12. So these are similar by SSS. And then finally, a quick check here. So 21 over 7, 12 over 4. We don't have the other side. We don't have an angle mark. So even though these two things are equal, there is no SS. So these are not similar. We don't have enough information for that number 11. The 5 valid congruence theorems, right? So we switch gears. That's SSS, SAS, ASA, AAS, or SAA. The same thing. And then finally HL, where HL was SSA with a right angle. So springboarding off of SSA, it's not valid by itself, right? You have to have the right angle. And then the other one that you're not allowed to use with congruence that you did with similarity was just all angles. So look at a couple quick examples. There's an angle, a side, a side, side, a side, an angle. Well, this is SSA, not allowed, but there is a right angle, which means we actually have HL. Next one, you got an angle, but we don't have anything else marked, so these two are not congruent. Here we got an S, an S, an S. We got SSS in both triangles, which means these are congruent by SSS. And then go ahead and mark the vertical angle. You got an A, an S, and A, an S, and A. So these are congruent by A, excuse me, S, A. Next page. Using the mid-segment, remember the mid-segment? Formula for you is 2 times the mid-segment equals the base. So that's just the setup for all of these. Now, I don't really have enough room at the top. However, if I know that the base is twice, so 18 is 2 times as big as x, this one's pretty straightforward, and it's 9. Here, we do 2 times 5x equals 70. So we have 10x equals 70, which means divide both sides by 10, x equals 7 in number 2. Then we got 2 times 3x equals 84. So 6x equals 84, and if we divide both sides by 6, we end up with x equals 14. Here the algebra gets a little bit more involved, so 2 times x minus 1, right? This is the mid-segment, so 2 of those equals 45. Make sure you distribute. So 2x minus 2 equals 45. Add 2 to both sides, so 2x equals 47. Divide both sides by 2. X equals 23.5. Here, 5 is the mid-segment, so we do 2 times 5 equals x minus 1. So we have 10 equals x minus 1. Add 1 to both sides, so x equals 11. Here we do 2 times 4 equals 5x minus 2. So again, double the 4. We'll go ahead and solve this. So 10 equals 5x. Divide both sides by 5. X equals 2. With the triangles, remember the angles of a triangle sum to 180. So it's just a matter of putting all this together. 2x plus 1 plus 5x plus 5 plus 90 equals 180. If I combine my like terms, I got 7x plus 96 equals 180. Subtract 96 from both sides. So 7x equals 84. Divide both sides by 7. X equals 12. Alright, so this next one, 8x minus 1 plus 3x plus 4 plus 3x plus 9 equals 180. I'm going to go ahead and put all my like terms together first. So 14x, 8 plus 3 plus 3. We have negative 1 plus 4 plus 9, which would put me at plus 12 equals 180. Subtract 12 from both sides. So 14x equals 168. Divide both sides by 14. Here we go again. It actually equals 12 in this one as well. And then finally, 7x plus 8 plus 7x minus 1 plus 5x plus 2 equals 180. So let's go ahead and combine my like terms. So that's 14, 19x, 8 minus 1 plus 2 plus 9 equals 180. Subtract 9. 19x equals 171. And then 171 divided by 19. Divide both sides by 19. X equals 9. And then the final problem on here is this proof. It didn't copy over well for me. So we're trying to prove that triangle UVT is congruent to triangle XVW. So the statements, what I'm told at the beginning, that UV is congruent to XV. So let me go ahead and mark that. UV, XV. That angle UVT is congruent to angle XVW. So UVT, XVW. And then TV is congruent to WV. And I'm kind of running out of room, so I'm just going to put this here. TV is congruent to WV. Well, actually, in both of these, that is all given to me. So here's an example. You could put given twice. The only reason I'm doing it is because I ran out of room, and I actually don't have to go anything else. Those are vertical angles, but the fact that it's given to me means I can just go ahead and say that that's given, right? Right here it is. That's given. So let's just put given. Why not? And then those two triangles, if we look closely, there's an S, there's an A, there's an S. They're congruent by SAS. So we have reached the end of this proof. And really, it's just a matter of writing down the given and marking the triangle correctly.